Dear students, today we will look at a very interesting chapter taken from Class 8 English Balbharati textbook from Unit 4, that is Ramanujan. The images used in this video are taken from different internet websites. This video is presented by Miss Grecienne Misquitta. Today, students, let's talk about some of the famous mathematicians who have contributed a great deal in the field of mathematics. Starting off with Aryabhatta. Aryabhatta has been given the credit of inventing zero. Apart from zero, Aryabhatta has contributed in many fields. He also invented the number system what we use today. He was a great scientist and mathematician who introduced basic mathematics that children are taught today in every school around the world. It is also said that he came up with the area of a triangle and volume of sphere. Somewhat there is no substantial proof to state that. He is not only a mathematician or a scientist, but he was also an astronomer. He is also known for calculating the circumference of the earth, which is an approximation, and suggested that the apparent rotation was due to the axial rotation of the earth on its axis. He was the first known astronomer to devise a continuous counting of solar days, designating each day with a number. He asserted that the planets shine due to the reflection of sunlight, and that the eclipse occur due to the shadows of moon and earth. Moving on to the next mathematician of India, that is Brahmagupta. Brahmagupta was one of the first and greatest mathematician of his era. He is one of the most renowned mathematician of the 7th century. He was not only a master of astronomy, but he was also an expert in mathematics in topics like algorithm, algebra, trigonometry, and geometry. Brahmagupta was an Indian mathematician and astronomer. He has been given credit for his contributions to mathematics and astronomy, as well as he is also the author of many books related to math and astronomy. This was his first book and one of his most important works, that is Brahma Siddhanta. He also wrote about zero as a number rather than a simple placeholder. The idea of zero as a number has had far-reaching implications for math as we know it today. He also gave 22 upon 7 as value of pi and suggested 3 as a practical value. He is also well known for cyclic quadrilateral and indeterminate quadratic equations. Now, let's talk about his contributions to astronomy. He was the head of Astronomical Observatory in Ujjain and has written 25 chapters on it. He is also known as the father of arithmetics. Well, students, now let's talk about an English mathematician who played a vital role in the field of mathematics as well as in this chapter. That is Godfrey Harold Hardy, also known as G.H. Hardy or only Hardy. Godfrey Harold Hardy was born in Surrey, England. He was an eminent 20th century English mathematician. He expanded the domain of mathematical analysis. He is well known for his achievements in the number theory. Two of the most monumental works of Hardy were Mathematical Analysis and Analytic Number Theory. He collaborated with John Edensor Littlewood to work on these projects. They proved prime number results and conditional results, which were of primary importance in number theory. Hardy is also highly recognized for formulating the Hardy-Weinberg principle. It was G.H. Hardy's preference that his work is to be considered as pure mathematics. He is also known for his adoption and mentoring of the self-taught Indian mathematical genius Srinivas Ramanujan. He worked as a lecturer at Cambridge while he continued his research work. After some time, Hardy left for Oxford to take the Savilian Chair of Geometry at Oxford. Well, students, now let us begin with this chapter. This chapter, Ramanujan, is about a mathematical genius who contributed in many ways in the fields of mathematics. One morning early in 1913, Hardy found among the letters on his breakfast table a large untidy envelope decorated with Indian stamps. When he opened it, he found sheets of paper, by no means clean, on which, in a non-English script, were line after line of symbols. Hardy glanced at them without enthusiasm. So this para talks about how Hardy found an envelope written to him with some papers that were having some mathematical symbols on it, and it was written in a non-English script. That means it was not in an English language, and he glanced at the paper without excitement. He was not very interested to read that envelope. He felt more than anything bored. He glanced at the letter written in halting English, signed by an unknown Indian, asking him to give an opinion of these mathematical discoveries. The script appeared to consist of theorems, most of them wild or fantastic looking. One or two, already well known, laid out as though they were original. There were no proofs of any kind. Hardy was not only bored but also irritated. It seemed like a curious kind of fraud. He put the manuscript aside and went on with his day's routine. In this paragraph, we understand that how Hardy opened that envelope and started reading the scripts that were present in the envelope. Manuscript is basically a handwritten document. In those scripts, there were different types of mathematical theorems that were present. And in that, he also found that there were 1-2 theorems that were already put out before this Indian, could find out about them. So he thought that this Indian is some kind of a fraud who has written to him along with this theorem. So now he was not only bored looking at that manuscript, but he also got very irritated. He got annoyed. But then he also was curious to find that only 1-2 theorems were almost alike, the others were different. But then he decided to continue on his same old day's work. After lunch, he loped off for a game of real tennis in the university court. If it had been summer, he would have walked down to Fenner's to watch cricket. In the late afternoon, he strolled back to his rooms. That particular day, though, while the timetable wasn't altered, internally things were not going according to plan. At the back of his mind, getting in the way of his complete pleasure in his game, the Indian manuscript nagged away. Wild theorems. Theorems such as he had never seen before nor imagined. A fraud of genius. So in this paragraph we understand, after lunch, Hardy moved along with easy steps for a game of tennis at the university court. If it would have been summer, he would have gone to watch cricket at Fenner's. But late that afternoon, he goes back to his room. Even though his timetable wasn't changed, he could not do things like usual, and he kept wondering about the Indian manuscript that was playing in the back of his mind. And he could not enjoy his game as that manuscript kept nagging him away, which means he was getting annoyed due to that puzzling script, as he was unable to figure out those wild theorems which he never came across even once in his lifetime, and wondered, was that Indian a fraud of genius? A question was forming itself with epigrammatic clarity. Is a fraud of genius more probable than an unknown mathematician of genius? Clearly, the answer was no. Back in his rooms in Trinity, he had another look at the script. He sent word to Littlewood, probably by messenger, certainly not by telephone, for which, like all mechanical contrivances, including fountain pens, he had a deep distrust that they must have a discussion after all. In this paragraph, we understand that a question was arising in Hardy's mind in an epigrammatic clarity, that is, in a clear and witty way, whether he is a fraud of genius that is more possible than him being an unknown mathematician of genius. Clearly, the answer was no. So he went back in his room at Trinity and looked again at the script, and then he asked to see Littlewood, that is, Jack Littlewood, who was also an English mathematician just like him, and he did not call him using a telephone but sent a messenger, as he did not trust or thought gadgets and appliances to be reliable enough, and then decided to have a meeting regarding this after dinner in the dining hall along with Littlewood. Before midnight they knew for certain the writer of these manuscripts was a man of genius. That was as much as they could judge that night. It was only later that Hardy decided that Ramanujan was, in terms of natural mathematical genius, in the class of Gauss and Euler, but that he could not expect, because of the defects of his education and because he had come on the scene too late in the line of mathematical history, to make contributions on the same scale. In this paragraph, we understand that before midnight, Hardy and Littlewood came to the conclusion that the writer of the manuscript was a man of genius. Hardy realized that Ramanujan was a natural mathematical genius from the class of periods of Gauss and Euler. Gauss is a German mathematician and Euler was a Swiss mathematician, but he could not expect, due to the defects in Ramanujan's education, and that he had been known very late in the line of mathematical history, to make the same levels of contributions in the field of mathematics. Carl Friedrich Koss was born in Brunswick, Germany. He was a German mathematician who contributed in many fields like number theory, astronomy, geophysics, statistics, algebra, etc. He was not only a mathematician, but he was also a physicist and an astronomer. When he was a teenager, he became the first person to prove the law of quadratic reciprocity, which is a math theory to determine whether quadratic equations can be solved. He also discovered Bode's law, the binomial theorem, and the arithmetic geometric mean, as well as the prime number theorem. Gauss is also known for inventing the heliotrope, which worked by reflecting the sun's rays using a design of mirrors and a small telescope. However, inaccurate baselines were used for the survey, and an unsatisfactory network of triangles. Over the course of his life, Gauss wrote dozens of papers which dwelt in geometry, cartography, planetary magnetism, and electricity, and earned him prestigious Copenhagen University Prize in the year 1822. His contributions to the field of mathematics was so great that he was known as the Prince of Mathematicians. Leonard Euler was an 18th century Swiss mathematician and physicist, as well as the founder of pure mathematics. He was a scholar who was responsible for developing many concepts that are an integral part of modern mathematics. Euler came up with an array of principles which laid the foundation for much of modern mathematics as we know it. He was a revolutionary thinker in the fields of geometry, trigonometry, calculus, differential equations, number theory, and a legion of other accomplishments. His Euler's identity theorem is often rooted as the most delightful of equations, and his works also focused on the field of astronomy, lunar motion, acoustics, mechanics, and music. He also developed methods for solving problems in observational astronomy and demonstrated useful application of mathematics in technology and public affairs. Euler's legacy has been enormous in terms of shaping the modern playing field of mathematics and engineering, with his works highlighted by the Mathematical Association of America and honored by mathematicians around the world. Euler was a highly prolific author, having written hundreds of papers and publications over his lifetime, including the well-known Science and Philosophy series, Letters to a German Princess. The following day, Hari went into action. Ramanujan must be brought to England. Hari decided money was not a major problem. Trinity had usually been good at supporting unorthodox talent. The college had been the same for Kapitsa a few years later. Once Hari was determined, no human agency could have stopped Ramanujan, but they needed certain amount of help from a superhuman one. Kapitsa was a Soviet physicist and a Nobel laureate. Ramanujan turned out to be a poor clerk in Madras, present-day Chennai, living with his wife on £20 a year. He was usually strict about his religious observances, with a mother who was even stricter. It seemed impossible that he could break the ban and cross the water. Fortunately, his mother had the highest respect for the goddess of Namakal. One morning, Ramanujan's mother made a startling announcement where she had a dream the previous night in which she saw her son seated in a big hall among a group of Europeans, and the goddess of Namakal had commanded her not to stand in the way of her son fulfilling his life's purpose. This, say Ramanujan's Indian biographers, was a very agreeable surprise to all concerned. Here in this paragraph, we understand that Ramanujan was a poor clerk living on only rupees 2000 a year. He was very strict about all his religious practices, and his mother, who even followed those religious practices much more than him, where he was not allowed to travel across the sea or the ocean. But as his mother had a dream where she saw her son seated in a big hall with Europeans, that's how she realized that the goddess of Namakal had given her the order to not stand in the way where her son could reach greater heights. Now students, let us have a quick revision of the things we learned today in this video, starting off by answering some of these questions. What did the manuscript contain? The answer is very easy. The script consisted of theorems, most of them wild or fantastic looking, one or two already well known, laid out as they were original. There were no proofs of any kind. Everything was written in a non-English script. There were line after line of symbols. The second question we could talk about is, why could Hari not enjoy his game? Well, students, now you know the answer to this as well. At the back of Hari's mind, the Indian manuscript was getting in the way of his complete pleasure in his game. As you know, there were wide theorems such as he had never seen before or never imagined. The question worrying him was whether it was a fraud of genius. This question kept on nagging him. Hardy, that's why, found it hard and could not enjoy his game. Moving on to the next question. What did the two English mathematicians realize by midnight? The two English mathematicians knew for certain that the writer of those manuscripts was a man of genius. That was what they could judge that night. The fourth question. What were two drawbacks in Ramanujan's career? So we also learned that there were defects in his education and Ramanujan had come on the scene too late in the line of mathematical history. These are the reasons Ramanujan could not make contribution on the same scale as the great Koss and Euler. The last question. What superstition did Ramanujan's mother believe in? Ramanujan's mother had a dream in which she saw her son seated in a big hall among a group of Europeans, and the goddess Namakal had commanded her not to stand in the way of her son fulfilling his life's purpose. This is what the mother believed. Thank you, dear students, and hope you all enjoyed this video.